This is Chemistry Unit 7, Stoichiometry. So our next stoichiometric reaction involves moles and mass. So let's check out example 2b. Look at the following equation. Solid carbon, which is the 5C, plus sulfur dioxide gas, that's my 2SO2, react to produce carbon disulfide, which is CS2, and carbon monoxide gas, that's the 4CO. So let's look at question 1. It says how many moles of carbon disulfide, which is this one, CS2, gas form when 2.7 moles of solid carbon reacts. So we have 5 moles of carbon in the reaction, but now we're changing that to 2.7 moles, and I'd like to know how many moles of carbon disulfide will be produced. So this might look familiar to you. This particular problem is still a mole-to-mole reaction, and that's to help refresh your memory about that mole-to-mole reaction because you will need it in the next two questions, and then also go one step further. So this is just a little refresher. You have 2.7 moles of carbon, that's my starting point. You can see the mole-to-mole reaction in my t-square. Carbon is on the bottom because we want it to cancel, and you're looking to find carbon disulfide, or CS2. Where did the 1 and the 5 come from? It's the coefficients. There's nothing in front of CS2, so that indicates 1, and there's a 5 in front of carbon. Now to solve this, 2.7 times 1 divided by 5 is 0.54, which matches my significant figures. There's 2 and 2.7, and 2 and 0.54 indicate your unit, which is mole, and the substance you're trying to find, CS2. Now look at question 2. How many grams of carbon are needed to react with 5.44 moles of sulfur dioxide? So now instead of 2 here, you have 5.44 moles of SO2, and you're being asked to find grams of carbon. So let's see how this is done. You start with what was provided. Always you start with that number, right? 5.44 moles of SO2. That's all you can start with. Okay, that's what was provided in the problem. Now your next step, if you're starting with mole, your next step is still that mole-to-mole ratio. So you can see I have mole-to-mole written. SO2 is in the bottom. Why? Because I want to cancel it. And C is written on the top, because that's what I'm trying to find. Where did the 5 and the 2 come from? It's coming from the coefficients. There's a 5 in front of carbon and a 2 in front of SO2. So this should look familiar. Now, why do I have this next step? Well, if you just stopped here, you would be left with moles of carbon. That's not what you were asked to find. You were asked to find grams. So now you need to use a conversion factor that you've seen before. It's called the molar mass. So you can see I have 1 mole of carbon on the bottom and 12.01 grams of carbon on the top. Where am I getting this from? Molar mass is from the periodic table. So here's carbon, right? You can see the 12.011, and if it's molar mass, that 12.01 grams is equal to 1 mole. Why did I put the 1 mole on the bottom? Because I'm trying to eliminate the moles and be left with grams, because that's what was asked of me in the question. And now to solve this, this is where I stress the use of parentheses. It isn't mandatory, it just helps keep the calculator on track with what you're trying to solve as well. So it's up to you if you use parentheses or not, but when I teach you how to solve these, I will use parentheses. So if you have your calculator, you hit the left parentheses, 5.44 times 5 times 12.01, and then close with the right parentheses. And then I hit divide, parentheses, 2 times 1, close the parentheses, and you get, rounded correctly with my significant figures, 163 grams of carbon. So I had 3 significant figures in 5.44, so there's 3 in my answer. I provided the unit and also the substance that I'm looking for. Okay, now let's try one more. How many moles of sulfur dioxide are needed to make 118 grams of carbon disulfide. So you know how much product you have. You have 118 grams of CS2, carbon disulfide. Now, what you're trying to find is how many moles of SO2 do you need to make that much product. So now you're starting with gram and being asked to find moles. So you're basically reversing what we did in step 2 here. So let's see how this works. So you always start with what you were given, 118 grams of carbon disulfide. So now if you're starting with gram, the place to find grams, to use grams in this type of stoichiometry, is the periodic table, because that helps you to get molar mass. So if you look, I have 76.13 grams of CS2 in 1 mole of CS2. Where did I get this from? If you look on the periodic table, you add 1 carbon, 2 sulfurs, and you will get 76.13 grams of CS2. That's molar mass, so it's comparable to 1 mole. Now you can't stop here because you were not asked to find moles of carbon disulfide. You want moles of sulfur dioxide. So this involves one more step, and it's that mole to mole ratio again. So you can see it right here. I've got mole to mole. CS2 is on the bottom because I'm trying to cancel it. SO2 is on the top. Where did I get the 2 and the 1? It's the coefficients. There's a 2 in front of SO2. If there's nothing in front of CS2, that indicates 1. All right, and again, I'm going to recommend parentheses. So if I were to solve this, I'd hit the left parentheses, 118 times 1 times 2, and close it with the right parentheses. Then you hit divide, parentheses, 76.13 times 1, and close your parentheses. Now you get a lot of decimals. I have 3.09999605994. That's not necessary, right? This is why we learn significant figures. So I have 3 and 118, and you need to round that to 3.10. Include your unit, which is mole, and the substance you're trying to solve for, which is SO2. All right, example 2b. Iron 2 oxide, which is FeO, reacts with carbon monoxide, that's CO, carbon dioxide, CO2, and iron, Fe, are produced. So that is my balanced equation. Now from this, let's try to solve a couple different problems here. So if you look at problem 1, how many grams of carbon dioxide, so that's CO2, will result if 3.16 times 10 to the minus third moles of iron 2 oxide are used? So this is still a mole to mass problem, but I wanted to make sure I provided scientific notation here because a lot of students get confused. They think that this changes everything, and it does not. You've seen scientific notation before. It doesn't change anything. You just have to remember how to plug that into your calculator. So what are we starting with, and where are we trying to end up? Well, you are starting with 3.16 times 10 to the minus 3 moles of FeO. So right in our balanced equation, we have 1. But now here we have quite a bit less than 1. And we're trying to find out how many grams of CO2 will this yield. So this is a mole to mass problem. So here are the moles that you're starting with. And it's FeO, it's my iron 2 oxide. Now if you're starting with mole, your next step is the mole to mole ratio. So you can see it right here. FeO is on the bottom so that it cancels. CO2 is on the top because that's what I'm trying to find. Why are these both 1? Because this equation is balanced with no coefficients, so everything is a 1. So FeO cancels, and now you're left with moles of CO2. That's not what you were asked to find. You want grams of CO2. So you can see in my next step, I'm using molar mass. So 1 mole is on the bottom, 44.01 grams is on the top. Where did I get that information? The periodic table. 1 carbon, 2 oxygens provides 44.01 grams. So mole is on the bottom so that it cancels, and gram is on the top. And now again, I cannot stress enough the use of parentheses, but also remember to use the EE key, not times 10. So if you're to type this in, I hit the left parentheses, 3.16, hit the EE key, -3, times 1 times 44.01, and close the parentheses. Okay, now you can hit divide and parentheses 1 times 1, but anything times 1 is just itself, so that's not really necessary. And now when you see your answer, you need to make sure you match your significant figures to 3.16. So there's 3 in 3.16, and there's 3 in my answer. So this is rounded to 0.139. Include your unit, which is grams, and the substance you're trying to find, CO2. Okay. All right, let's try one more. All right, 63.1 moles of iron was produced when iron 2 oxide and carbon monoxide react. How many grams of carbon monoxide was used? I know there's a lot of formulas here, a lot of substances have been named, but you have to look at your starting point and what you're trying to find. So your starting point is 63.1 moles of iron right here. Okay, it says that was produced, and all that this is describing is the reaction. It said when iron 2 oxide and carbon monoxide react. So when these two react, you get so many moles of iron. How many grams of carbon monoxide was used? So to make so many moles of iron, how many grams of CO is needed? Okay, so this is mole to gram. So you start with 63.1 moles of iron. That's what was provided in the problem. Now, if you're starting with mole, you need to use that mole to mole ratio. So you can see mole to mole is written. Fe is on the bottom. CO is on the top. Why are these both ones? Because my equation is balanced. There's no coefficients. So that's assumed to be 1. So if Fe cancels and you're left with mole of carbon monoxide, CO, that doesn't answer the question. The question was how many grams of carbon monoxide was used. So now you need 1 mole of carbon monoxide, and where am I getting the 28.01 grams? That is from the periodic table. So carbon, 12.01, and then oxygen, add that together, and you get 28.01 grams of carbon monoxide. Okay. So remember, mole is on the bottom so that it cancels, and I'm looking for grams. Now to solve this, you have a lot of 1s in here, so you are free to eliminate the 1s, but if you need them, it will still work. So you would take 63.1 times 1 times 28.01, and if you need to, you can divide that by 1, but it's actually just not necessary. Now I wanted to show this type of example to help you remember your significant figures. So this is what you get in the calculator, right? And you need to narrow this down to 3 significant figures because 63.1 only has 3 significant figures. So just remember that one way to do this is you can write 1770 because that 0 does not count. But if that was kind of tough, you can always put this into scientific notation. So 1.77 times 10 to the third will work as well. Either one of these is correct significant figures. Don't forget your unit, which is grams, and the substance, carbon monoxide.